we're asked to find the sense, magnitude, and direction of the following vectors. And it says, note, the units are in centimeters. And then it says, round to the nearest one decimal place. That's what this means. So let's start with vector D. Well, we need to find its sense, its magnitude, and its direction. Let's go ahead and start with its sense. Okay, well, its sense, well, it's just going straight up. So straight up. What about its magnitude? Well, since it's going straight up, there isn't really anything to calculate. The magnitude is just how far it went. Well, at 5, we said centimeters. The magnitude is just 5 centimeters.
Straight up.
And that's based on its x and y components. Its y component is positive 5. And its x component is, of course, 0. And we didn't need to write this out, but it will help us later on, so we will. And what about its direction? Well, the direction, of vector D, well, that's just basically 0 degrees off the y-axis. Or I guess you could also say 90 degrees off the x-axis. And you might say, what about the clockwise and counterclockwise stuff you mentioned in the last video? Well, if you really think about it, as long as you have the y component or the sense, they're kind of all saying the same thing. It's saying it's going 0 degrees. Well, which 0 degrees? Is it going up or down? Both of those would technically be 0 degrees. Well, it's up because we look at our sense, or we look at our y component, which is positive 5. It tells us it's going up. So from there, let's go ahead and work on vector E. Well, vector E has a sense. Let's go ahead and pick our colors again. Its sense is clearly going down and to the right. So it's going down and to the right. Well, its magnitude we can figure out via its x and y component. So we have its y component. It's going down. And we'll call this just E of y. And it has an x component. It's going to the right. And we'll call this e to the x. So we have e to the x equals, and that's what, 5? And it's positive 5. And the only reason why we write positive there is to give us a sense. It won't change our math any. It'll just give us the sense of to the right because we're talking about the x. And then we say e in the y direction. Well, that's going down 2, so we'd say negative 2 since it's going downward. And again, that negative would again just give us our sense. The negative sign in this case in magnitudes don't really, or the components of vectors, don't really change the math. And you'll see that in a second. So let's go ahead and find our magnitude. And we know that it's just going to be a squared plus b squared equals c squared. So we start with a squared, which is what we could say is e to the y. So we'll say negative 2 squared plus b squared, which is positive 5 squared. So 5 squared. And that's going to be equal to vector e squared. Well, negative 2 squared, well, that's just negative 2 times negative 2 is positive 4. And we can add that to 5 squared, which is positive 25, is e squared. And that's equal to 4 plus 25 is 29. So to find our magnitude, we take the square root of 29. So we go to a second square root of 29. And so we'll just switch it by hitting this button right here. And it'll turn it into our regular number, and we'll round to the nearest one decimal place. So we get the magnitude is 5.4. So now let's find our direction. Okay, so the direction. Well, to find that, I'm going to go ahead and write it out. Direction equals question mark. Okay, I'm going to go ahead and redraw our triangle over here. So we have side E, which is 5.4. And we have its x component, which we did in red. So that's just, what, 2 or negative 2. It doesn't really matter. It's not going to change the math as we saw. And we have our, that was our y component. We have our x component as well. Let me go ahead and pick our x component in orange. And that is just 5. And so we want to know what our direction is, or our angle is. Well, we could use sine, cosine, or tangent, but I want to use tangent because, in this case, I could use any, but to get a more exact answer, I'm going to personally choose tangent because it's opposite and adjacent. We know these numbers are exact, whereas we rounded this number, so it's less precise. So it's just going to be equal to the inverse tangent of opposite over adjacent, which is 5 over 2, and whatever that is in our calculator, so we'll take the inverse tangent of 5 over 2. And we'll get an angle of 68.2 degrees. 68.2 degrees, which if we look is coming off our y-axis. It's 68.2 off of the downward direction, so from y-axis. And we could write out that it's coming, well, it's coming sort of this direction. It's coming up this way, which is a counterclockwise motion.
And we really should add that it was from the negative y-axis. That's actually really important. And so we get a final answer of a direction of 68.2 degrees counterclockwise from the negative y-axis and a magnitude of 5.4 for our vector.